Hello, my name is Risha, and this is me making a video explaining a chemistry topic that is pretty interesting to me. But first, before we begin, have you ever wondered why a lemon tastes sour, or soap tastes bitter, or why some substances can clean really well while others can actually burn your skin? Well, you might be wondering this too, as I was the beginning of my research. The answer to all of this is chemistry, specifically acids and bases. Acids and bases are two important types of substances that we encounter every day, both in science and in real life. First, let's start with acids. Acids are substances that release hydrogen ions, seen right there, also called H+ ions, when they are dissolved in water. These hydrogen ions are what give acids their special properties. One of the most noticeable properties of acids is their sour taste. For example, foods like lemons, oranges, and vinegar are all acidic. Acids also tend to be reactive. Some strong acids can even be dangerous because they corrode metals or damage skin. But not all acids are harmful. Many are safe and even essential, like the acid in your stomach that helps digest food. Now let's talk about bases. Bases! Again, bases are kind of the opposite of acids. Instead of releasing hydrogen ions, bases release hydroxide ions, also known as OH- ions. You can see that right there in the photo. Bases have their own unique properties. They often taste bitter and feel slippery. For example, soap feels slippery because it is a basic. And you see other examples like baking soda. Common other bases include baking soda, which I just mentioned, ammonia, and many cleaning products, as we see here. Just like acids, strong bases can be dangerous, so they should also be handled carefully. But now you may be wondering, well, how do we measure how acidic or basic something is, Risha? Well, we'll use something called the pH scale. The pH scale goes from 0 to 14. A pH of 7 is considered neutral, which means it's not acidic or basic. Pure water is a great example of this substance. If the pH is less than 7, like here, it is an acid. The lower the number, the stronger the acid. For example, something with a pH of 2 is a stronger acid than something with a pH of 5. If a substance has a pH greater than 7, it's a base. The higher the number, the stronger the base. For example, a pH of 12 is more basic than a pH of 9. Now, here's something really important. Acids and bases can react with each other in a process called neutralization. In a neutralization reaction, an acid and a base combine to form water and a substance you all know as salt. This reaction helps balance the properties of both substances. Now, you might be wondering, well, Risha, give us a real-life example. We already heard enough of this. Well, I got you. A real-life example is when people take antacids to treat heartburn. The acid in your stomach can sometimes become too strong. We've all had a stomach ache, and that causes extreme discomfort. Taking these types of medicines are more categorized as basic, so they neutralize the acid in your stomach and bring it to a more balanced state. And another example is agriculture. Farmers sometimes add basic substances to soil that is too acidic in order to make it better for growing crops. So now you might be wondering, why does this all matter? Now we've learned it, who cares? Well, understanding acids helps scientists, engineers, and create medicine, develop things like cleaning products, and even protect the environment. It also helps us understand everyday things, like why certain foods taste the way they do, or how products we use actually work. So, next time you drink some lemonade, or you use some soap, that was soap, by the way, I risked that, now I have to clean it off my laptop. Remember, you're experiencing chemistry in action. The end. Risha out. Thank you for listening.